Hello, everyone, and welcome to Invitation to Puzzles, where today we have a region sum lines puzzle for you. So in a region sum line, the thing to keep in mind is that the blue lines separate the line into groups of the same sum. So these three cells have the same sum as these three cells have the same sum as these three cells, for example. And this one cell has the same sum as these three cells. So this could have been an arrow, if you like. But of course, it doesn't have to be. We have a nice little, it looks like a jellyfish to me. I don't know. Do you see a jellyfish? What do you see? A little Sudoku Rorschach test. Okay. But I'll have a link down in the description, and we'll go ahead and try to solve this. So the first thing that strikes me is that I have all of these sort of could have been a length 3 arrow cells where the minimum sum you can get out of these would be 6. So all of these digits have to be from 6, 7, 8, 9. And we have some given digits to help. So we have this sort of cheeky 6, 8, 9 looking at this cell, which means that's a 7. And notably, that means this is also a 7 because they're both telling you that the sum of these cells is 7. And the only way that works is if these digits are 1, 2, and 4. That 7 now looks across and has made that an 8, which has made that a 9. Okay, and that an 8, and that a 7. So we have all of the sort of totals filled in here. Let's see, this is a 1, 2, 4, I see. And this is a 3-cell 8 sum that doesn't have a 3 in it. So 1, 2, 5 is actually the only option. So this digit is a 5 just by Sudoku, owing to some givens. I see the 1, 2 and the 1, 2 here look across. And so in this box, I need to put the 1, 2 here. This is a 1, 2 hidden pair, which makes these a 4, 5, 9. And apparently of those, that one's only able to be 4. Okay, now this region sum line here, we know the sum has to be 15 because the total sum of the column is 45. And so we have to divide that in 3 equal pieces of 15, which means this is a 2 when I do that. I do see that just by corner mark stuff, there's a 6 and an 8 up here. The 8 goes up there from that. The 6 goes up there from that. And those sum to 14. So this is actually a 1, 6, 8 is what I can see. And so this triple here has to be the other fellows involved, which seem to be a 3, 5, 7, which does indeed add to 15. That's always a good sign. This 5 is going to give us guidance on what's happening with this 8 sum. Namely, it's not 1, 2, 5, so it's 1, 3, 4. And that 1, 3, 4 looks across and makes that a 7. Let's see, looking across here, what is this? What's left in this row? We've got a 2... 3, 4, 5, a 6, and an 8. And of these, this one is only the 2. So we've got that. Let's see. This is at least 3, 5, because the 1, the 2, and the 4 are gone, and it can't be more than 3 plus 5, because that would make this digit more than 8, and it can't be a 9. So actually, I'm stuck here making this an 8 with a 3, 5. Which is resolved. 3, 4, 5, 6. Let's see. So these are a 7 and an 8, and the order is resolved by that. Let's see. These are 3, 6, and 7. And these are 4, 8, and 9. For what it's worth. Let's see. Maybe I should do the same trick with this line. These sum to a minimum of 3 plus 6. Yes. Fun fact, 3 plus 6 is 9. So that's a 6 and a 3 gives me an 8 and a 6, and sort of tears through this box over down here. Okay, so now the only digits left in this box are 1, 2, 3, and 4. And the only way I can make 9 out of those is to maximize it as 2, 3, and 4. So we can fill that in. So 4. So that's a 1 by virtue of the fact that I said the only digits we had left in the box are 1, 2, 3, and 4. And then I put the 2, 3, and 4 in. Let's see. These are a 7 and an 8 in some order. Let's see. That's a 1 just because this one looks at that cell, and that's a 4 because 4 is the digit left in the box. Okay, what about these digits? These are a 7 and a 9 that go in by Sudoku. And so now, oh, and this is a 3 because that's a 1-4 pair. But in particular, I know what these 3 digits are, so I'm going to know what their sum is. It is 2, 5, 6 is what's left. So 2, 5, and 6 sums to 13. So these 4 digits need to sum to 13. So one thing that certainly tells me is there's not a 9 on this line, because if there were a 9 on this line, the minimum the line could sum to would be 9 plus 1 plus 2 plus 3, which is already 15, which is more than 13. So by Sudoku, the 9 in this box is here. Let's see. The 7 in this box. The 7 in this box is here by Sudoku. It gives me 8, 7 over there. Gives me that 8 as well. Let's see. In fact, actually, what's 1, 2, 4, 5? 1, 2, 4, 5. 1, 2, 4, 5 is the minimum this can sum to. That is 12. So the actual only way I can do this is as 1, 2, 4, 6. And I'll explain that just in case you haven't seen this trick before. If you minimize it, you of course hope that when you minimize it, you'll get it exactly right and then you win. But if you minimize the total and it turns out you're just 1 under, and you have a string of digits like this with the 4 and the 5, the only way that you can be just 1 under and have it be correct is to replace the highest digit that you have in your minimum with 1 higher. And so in this case, it would be 1, 2, 4, 6 is actually the best. You also could have done 45 math in the box and summed like these and 13 and concluded that this digit was a whatever this digit is. It's a 5, I think. That is also an acceptable. There's lots of acceptable ways to do it. Acceptable sounds too judgy. It's also a reasonable, there we go, that sounds less judgy, way to do it. So there's a 2, a 1, and a 4. Okay, and then we have our stuff going in here. So there is a 3. A 2, let's see, one of these is a 4, and it's that one, and a 5 goes there. Very nice. Thank you, everyone, for watching. Let us know how you enjoyed that. I think this is like very much in line with the sort of stuff that you'll see over in like the Daily Sudoku Gas forum and that kind of thing. If you look at those kinds of puzzles, I think you'll find stuff like this. I found that very nice. All right, thanks for watching. I hope to see you next time on Invitation to Puzzles.